Okay, we're going to talk about going from formula to name for transition metals because this is different than you would do for any other formula. So if there's a transition metal or an element 14 or column 14 element, you have to use this method. So first, let's give ourselves an example formula. Let's give ourselves MnO. So the sample formula we're going to be given is MnO. So normally we always pull the cation first. We cannot pull the cation first for a transition metal because it might have more than one charge. So you're going to go ahead and pull the anion first. So for MnO, we know the anion has to be O because it's written second. So when we look up O on the periodic table, it's in column 16, and column 16 has a charge of 2 negative. And if you're wondering why we use anions, it's because no anion has multiple oxidation states, so they're stable. So we can base everything off of the anion. We can go ahead and write down our cation, but we want to name our anion first. So our anion O2 negative, we can name it as oxide. We can go ahead and identify our cation. And that's going to be Mn. We know it's going to be positive something, but we don't know the charge yet. We have to figure out the charge. But we can name this as manganese because Mn is manganese. We are just missing what's going to be inside those Roman numerals because for transition metals and column 14 elements, you have to give the charge in Roman numerals. So what we do is we do an LCM chart with what we have. So we can go ahead and identify we have Mn and we have O. We know the charge of O is 2, and we can look up here and go, well, I just have one of them. We know that we don't know the charge of manganese, but we can look up here and go, I have one of them. Well, we can use this chart to go, okay, oxygen's filled in fully. So 2 times 1 gives me an LCM of 2. That means that has to be a 2 up here, because remember, your LCMs always have to be the same for both rows or whatever row you're using, which means we can then go backwards and find the charge of manganese, because whichever makes this true here, what number makes that true there is your charge for your transition metal or column 14 element. So what times 1 equals 2? That's 2. That means that this must be a manganese 2. So I can go in and fill that in. I can put the Roman numerals here too, and then I can go ahead and write the full name together. So this is manganese 2 oxide. Okay, let's do another example. Let's do Cu4 SiO4. Cu4 SiO4. So the first thing you recognize is you have to pull your anion. Well, SiO4 is written last. That has to be your anion. And you know it has a charge of 4 minus because you've memorized that this was silicate. And silicate has a charge of 4 minus. Then you got to pull your cation. You know that it's going to be Cu because it was written first. We don't know the charge because Cu is a transition metal or a column 14 element, and you have to know that it has multiple oxidation states but we can know that the Cu is written as copper. We are just missing what's going to be in the parentheses. That's your Roman numerals. So from here, you can go ahead and make your LCM chart. Now I'm going to pull down my Cu. So I'm going to write Cu. We don't know the charge yet, but we know there's 4 of them because of this subscript next to Cu. So we can do this times 4 is going to equal something. We don't know that LCM yet. Then we're going to go ahead and pull down silicate. So we have SiO4, 4 minus. We know the charge of silicate is 4 minus, or 4. So that's the charge number that we're going to use here. Then you look back at your balanced compound and see that there's no parentheses around silicate. So there has to be one of them because it's written 1 time. So 4 times 1 gives you your LCM. So 4 times 1 is 4. So we must go ahead and pull up this 4 for this LCM here because you use it for both. Then you complete this equation. What times 4 equals 4 to get the charge for copper? The answer to that is 1. So the charge of copper has to be 1. So now we know that this is going to be copper 1, and you fill that in with 1I because 1I is a charge of 1. And now we can write our balance or the name of our copper compound as copper 1 silicate. Okay, let's do another one. We're going to do Cu2 SiO4. Cu2 SiO4. So the first thing you do is pull apart your anion and your cation. We know our anion has to be SiO4. It is written second. We can go ahead and fill out the charge for SiO4 because it's silicate, and we know the charge of silicate is 4 minus. And then we can go ahead and write the name of this down as silicate. Then we know that our cation is written first. It's copper. We can write that as Cu, and we can start writing copper. But we do not know what is in the parentheses yet because copper is a transition metal with multiple oxidation states, which means you might have copper 1, 2, 3, or 4. So we have to use the LCM method to figure out what goes in those parentheses. So we start our LCM chart. We go ahead and pull copper down. So we have Cu. We do not know the charge of copper. Remember, charge always goes first. We can fill it out. So something times, now we look back up into our equation, and our subscript is 2. So something times 2 will give me an LCM that I still have to figure out. Then we have silicate, that's SiO4 4 minus. Okay, we know the charge of silicate, the number that we're going to pull here is 4. And we look back up at the balanced compound and we don't see a parentheses and it's written 1 time. So I go ahead and know that there's only 1 of silicate. So 4 times 1 gives me my LCM of 4. I can go ahead and take this 4 and put it in this blank because the LCMs have to be the same both ways. Both lines have to have the same LCM. Now we can solve this equation. What times 2 gives me 4 to find the charge of copper? And the answer is 2. 2 times 2 equals 4. So now that I know that to be true, I go ahead and put 2 capital I's into that parentheses because we know it's copper 2 and we represent that with 2 I's. Now down here, we can write our entire balanced compound as copper 2 silicate. And that is how you do that name, the transition.